Hi, I'm Cordula, co-founder at XYZ Technical Art Services and an Unreal authorized instructor. One of our favorite tools is reality capture, and in this tutorial I will show you how you can create a height map for use in Unreal Engine from real-world environment captures. Reality capture is best known as a photogrammetry application which is used to create 3D models. It is also used for creating 2D representations of terrain data, and since reality capture version 1.5, it is possible to export orthographic data as PNGs with 16-bit color depth. This makes it useful for quickly creating height maps for naturalistic terrains, which can then be fine-tuned in Unreal Engine using its landscape tools. So the overall process we'll go through is, first, we process the photographs into a 3D mesh in reality capture. We then use reality capture's tools to clean the mesh. Still in reality capture, we'll create an orthographic projection and export it. We then have to make a tiny edit to the PNG in an image editor. And finally, we'll finish our import to Unreal and look at how we can edit our landscape. This process is not too complicated, but there are one or two things that can catch us out. And remember, you are creating raw material for further refining and editing in Unreal, so there is no need to be too perfectionist about it from the start. To get started with this workflow, you want to have Reality Capture 1.5 ready to go, an image editor like GIMP or Affinity Photo, and ideally you are familiar with the landscape tools in Unreal Engine. We also need some example data. In this tutorial, I'll be showing the process with photogrammetry of a small piece of rocky ground that will look a little bit like an alien landscape once it's in Unreal Engine. You can download the photographs we'll use from the box link in the video description. Of course, this process also works for drone images or videos of some natural terrain, so you can use those if you have them available and processed already. Let's open up Reality Capture, making sure that we are on version 1.5. The orthographic projection that will give us the height map will be created from a mesh, so we proceed just like you would with the creation of a 3D model. First, we import the photos as a folder, and then we align the images. Depending on your machine, this might take a few minutes. Once we see our point cloud, we can adjust the reconstruction region to contain just what we need from the point cloud, rather than reconstructing the entire capture. Let's also check what we have here from the orthographic views, say from the left. So in our example, we can already see that the model will be rotated slightly on an angle that we mightn't be too happy with. So there might be a chance of undercut, and we want to adjust the angle. We can do this easily by using the gizmo to rotate the reconstruction box. So we go to 3D Tools, and at the start we have Set Ground Plane. Here you can either manually adjust it or set it to the reconstruction region. So when we select Set by Reconstruction Region, the ground plane snaps to the box like this. Then with the reconstruction region selected, we go to 3D View, create a clipping box from the reconstruction region. That means that we only render what we need. There's no need to be too precise about this, as the next step also involves selecting specific areas of the reconstruction. This is a good time to save the project. Now let's reconstruct the mesh. In Mesh Detail Settings, we'll enable Remove Marginal Triangles so that we have an open mesh. That way we don't have to clean any polygons that are created around the bounding box. For the purposes of a height map, I don't need too much detail, so let's go with normal settings. And let the mesh cook for a few minutes. Okay, now that we have the mesh reconstructed, we can already see some nice features in this tiny patch of ground. Some erosion around the rock, and that depression in the ground around it. Scaled up, this will look quite geological. But we can also see there is a lot of noise in the model, all those little lumps. To ease this, we can smooth the surface to get rid of the worst of the noise. Go to Tools, select the Smoothing tool. In the options, we want to remove noise, just the peaks, and we leave the weight and number of iterations at default for now. We won't go over the top, but I do want to get rid of some of the peaks in what will be our terrain. So I'll use the values here in the settings, for example. Okay, that looks a bit smoother now. Depending on what type of result you're looking for, you may need to iterate a couple of times. For our alien landscape example, a few extra hills and rough terrain might work quite well. Now we're ready to start creating our height map. Let's bring the view to top view so we can see which areas might work best for us. Maybe here where there is a bit of water erosion around the rock, so we have a nice geological looking formation. The first thing we need to do is to make sure that the reconstruction region covers the entire height range we want to capture, so the highest and lowest points. It is also recommended to keep the region to a square aspect ratio. I just set this up roughly as we will be adjusting the area more precisely once the ortho projection tool is activated. The ortho projection tool lives here in 3D tools. When I activate it, these toggle, the ortho projection region appears. We use it to roughly select the square region we want to project for our height map. We also get the settings panel on the left. Using the width and height fields, we can more accurately adjust the size of this area. So let's quickly adjust the orthographic projection area. There is a feature helping us to figure out an optimal resolution based on nearby image detail. The smaller the detail, the higher the resolution it will give you. Let's try the estimate function. This brings the resolution up to about 16K. For performance, that is actually quite a high resolution. For this demo, let's keep it to a 4K resolution, 4096 by 4096. We can change the value in the tool details, but if we change one side, it will change the other side proportionally. If we want to adjust one side at a time to change the proportions of the area, we need to zoom in and adjust this in the viewport. This is a bit tricky to adjust, so zoom all the way in. There, nice and square. For this project, we are not going to worry too much about the scale itself, since we're intentionally creating a large terrain from a small area. If you are trying to recreate a terrain to actual scale, check the link in the description for more material on that in the Epic knowledge base. Let's render out the ortho projection using the render button. To see the render, find your projections here in the outliner under component. In ortho view, come to the image selection in the toolbar and select DSM, Digital Surface Model. You can choose a color palette that best represents the convention you are used to. You might recognize these from geography illustrations. From looking at the color scheme and gradient, you might notice something not quite right, which will become more obvious in grayscale. You probably know that in a height map, the peaks are lighter and the troughs are darker towards black, much like we can see in the model. Where the rock is should be white. So our height map is reversed. Why is that? This might happen to you if you're just working with the ortho projection widget in top view. Let's take a closer look, this time in perspective view. Using this widget, we can select the direction of the ortho projection. So in our project, we had selected the top rectangle of the widget. If we select the bottom one, we see the direction of the red arrows change. Selecting one of the gray squares at the corners turns it orange. Where this square is, will be the top left corner of the 2D height map we're creating. So let's try rendering this again. Now we can see that the height map is correct. The bright peaks correspond to where our rock or mountain should be. Of course, if you accidentally render a reversed height map, you can also reverse it in an image editor of your choice. Now let's prep our projection for export as a PNG so that we can use it in Unreal Engine. Make sure your ortho projection is selected in the outliner, and in the ortho 2D tools, we select Digital Surface Model. When we click on that, this triggers the export window. Select a location for your file and PNG as file format. When we hit save, it brings up another options window. As settings, we are choosing a grayscale image, since that's what the landscape tools in Unreal and most height maps are in. 16-bit should give a smoother result than 8-bit, so we'll go all in. Your pixel type needs to be set to altitude. And there we are, one height map. Now, if you're following along, you might want to hold off for a second before going into Unreal Engine, because we're going to have a problem with the color space of the height map. Let me just open a new Unreal project. I'm using a blank film template in Unreal 5.3. Here in landscape mode, I'll go to New. I'll go to Import from File and select our new height map. When I do this, there is this little yellow flag where Unreal is telling me that the height map is not grayscale but should be. What's up with that? Did we not select grayscale? Yes, we did, but in Reality Capture, the field is called Color Scheme. It's a color palette, which is not the same as a color space. Let's hop into a photo editor that can handle 16-bit PNGs. We'll take a closer look and we'll fix it. I'm here in Affinity Photo, but GIMP works as well. Up in the top line, we can see that yes, the image is in fact 16-bit, but in sRGB, meaning that it uses RGB values to create what looks like grey. Let's change the color space to grayscale. I'm going to Document, Assign an ICC profile, and I choose Grey 16-bit. Other image editors might have different flows. Just use the one that you're most familiar with. While we're here, we should also take a look at the height map's dynamic range, whether there is any clipping on either side of the histogram. This could be caused by not including all the terrain we wanted to project from in our reconstruction box. We check both left and right of the curve, and we see that the entire curve is contained on the graph, so we're good. Let's export it and call it height map gray. Back in our Unreal project, let's import our new height map. We can already see that the mesh now imports correctly, and the flag disappears. I'm going to click Fit to Data so that the landscape corresponds to the resolution of our height map. Again, scaling in landscapes can be quite involved, so that'll be for another video. We now click Import to solidify the landscape. So if we take a look around, we can see that it actually makes quite a bit of sense to create a height map from real-life materials. There's now a realistic underlying structure in the landscape that will take a very long time to sculpt. At the same time, there's quite a lot of noise, so some iteration will be needed. To edit your raw material, you can use Unreal's landscape sculpting tools. They are a great way of controlling the terrain where you need to. For example, try smoothing the terrain or add some extra erosion. To bring this even further, you can of course add materials and vegetation to start dressing your environment. In this tutorial, we walked through the process of creating a height map from a real-life scan in Reality Capture and importing it into Unreal Engine to help you get a really fast start on creating high-detailed landscape with a lot of naturalistic structure. This process of taking your own source material and detailing it will make your environments truly unique. Here are some ideas for an additional challenge. If you want to dive deeper into height maps, scaling, and the technical aspects of landscapes in Unreal, take a look at the links in the description, which will bring you to the Epic knowledge base. I hope you found this tutorial helpful. Keep an eye out for the next one. Happy world building and see you soon.